Property methods are a special kind of method. Often we want to have the value of instance attributes stay in sync, and property methods allow us to do that. So what do I mean by stay in sync? Well, let's say that we define a class for rational numbers, where I pass in the numerator and the denominator, and I represent the whole rational number as one object. And let's say I want an attribute that's the float value. That's the value I get by dividing the numerator by the denominator. Right now it's 0.6. But I also want this rational number to be able to change over time. So if I set the numerator to be 4 instead of 3, I'd like it to be the case that if I look up the float value now, it's changed to 0.8, which is what you get when you divide 4 by 5. Now the trick here is that there are no method calls in either of these two lines. We only have an attribute assignment statement and an attribute lookup statement. So somehow we need a mechanism to make sure that float value changes whenever numer changes. And let's say that I then change the denominator from 5 to 2. I'd like the float value to change along with that as well. So how do I make that happen? Well, the answer is to use property methods. The property decorator on a method designates that it will be called whenever it is looked up. So the way we'll implement this is to have float value actually be a method, only it behaves like an attribute, without any method call syntax. The point of property methods is to allow zero-argument methods to be called without an explicit call expression, so that methods just behave like attributes. So let's try to write this class for rational numbers, which gets initialized with a numerator and a denominator. And we need to keep track of the numerator and the denominator. And by the way, these names don't need to have anything to do with each other. But what we're doing here is we're setting attributes of an instance, whereas here, these were just passed in on construction. Okay, what else do we need? Well, we need a way to print out this rational number. So what's a good way to represent it? Well, we can return a string that says rational and then passes in the numerator and the denominator. And I'll do that using a special method on strings called format, which does substitution. So I can pass in arguments to format, and they'll be substituted for these curly brace spots. So I'm going to format it with the numerator and the denominator. Let's see what we've got so far. I can create a rational number representing 1/2, and it will print out as rational 1/2. Excellent. Now what if I wanted a string representation that was more human readable? Well, that might be just the numerator divided by the denominator, which I can write like that. And then if I print out a rational number, I'll get a human readable expression. Okay, we have most of the functionality we want, except for we need this idea of a float value, which should just be the numerator divided by the denominator. Now, just like this, when I run my code and I create a rational number, 3/5, and ask for its float value, I get back a bound method, not a number. I have to call it to get back a number, which is different from the behavior I showed you on the slide. Now, a simple change, where I designate this as a property, will change this behavior, so that now, if I ask for the float value, the method will be called, and instead of getting back the bound method, I get back the return value of calling the bound method, which is nice, because then if I create this rational number, ask for its float value, and then change it in some way, the float value will always stay in sync, even though it appears to be an attribute. And that's the whole purpose of property methods.